Today we're looking at introducing absolute values. We're going to go through what an absolute value is and how we can solve equations involving absolute values. So to start with, we're going to look at this number line just here. So what I want you to do is imagine that this blue line here is a blue car traveling 3 kilometers to the right, and our red car is traveling 3 kilometers to the left. So if we look at our blue car and we look at the distance traveled, you can see that we've traveled 3 kilometers. But if I look at the red car, notice that even though I've traveled 3 kilometers, according to my number line, I've actually ended up at -3. So what we can say about these two cars is that they've traveled the same distance, however, they've traveled in different directions. The other thing is, if I look at the next number line, so this one down here, imagine I have a car, another blue car, and it travels 5 meters to the right. So you can see here that, let's just say I've traveled 5 meters so far. But let's just say the car travels back 5 meters again. Now, according to the number line, that would mean I'd have to subtract 5. So here, the car has traveled, according to the number line, 5 meters to the right and 5 meters to the left. So overall, it's traveled 10 meters, but according here to my integers, it says 0. So that's where the absolute values come in handy. So here, what we can do is we've introduced, there are these two lines. So here, if I go back to my first example, what I can do is if I introduce these two lines, these lines represent the absolute value. And what they say is, they say take the positive of whatever is inside those two lines. So here, if I take the positive of -3, notice that I end up with 3, and can you see that more appropriately represents the distance traveled? If I look back at my next example, here what you'll notice is that I've traveled 5 meters plus, now notice instead of traveling back 5, I'm going to take the absolute value of 5. So can you say I end up with 5 plus 5, which is 10 meters. So here, if we look at our first dot point, the absolute value of x is the distance from x to the origin on the number line. Everything positive will stay positive. So here, the absolute value of 5 will be 5. Everything negative becomes positive. So if I had the absolute value of -5, then it will become +5. So looking at some examples down here. Here, for question 1, evaluate the absolute value of -10. So that will just be +10. For B, the absolute value of 5 will be 5 minus the absolute value of -4. Well, this -4 will become a positive there. So here I get 5 minus 4, which is 1. My next line, I have the absolute value of 2 minus the absolute value of -1, which becomes 1, plus the absolute value of -3, which is 3, and that is all squared. So here I end up with 1 plus 9, which is equal to 10. Now here we're going to look at some properties of the absolute value. So for question 2, for the following, we need to look at, is it true that if I have the absolute value of A plus B, will that also be the same as the absolute value of them separately? So let's try this with A. So with A, I'm going to let A equal 2 and B equal 3. So the right-hand side will be the absolute value of 2 plus 3. And we're going to see if it's equal to the absolute value of 2 plus the absolute value of 3. So here we end up with the absolute value of 5 and equals 2 plus 3, and 5 equals 5. So we can say, therefore, in this instance, it will be true. We're now going to look at B, and here notice that B has a negative number in it. So here, we're going to take the absolute value of -3 plus 4, and we're going to see if it equals the absolute value of 3 plus the absolute value of 4. So here I get the absolute value of 1 is equal to 3 plus 4. And what you'll notice that they are not equal to each other. So therefore, false. So here, what we can say is that with the absolute value, we can't always split it up. So that's one of the properties that we have to recall. So we need to work with what's in the absolute value signs rather than splitting them up. So in this next table, we're going to have a look at some other properties. So here, notice that what I can do is that if I have two numbers multiplied, those I can split up. So think of it like our surds. So the absolute value of 2 minus 3 is the same as if we were to multiply them separately. Here, the absolute value of a all squared is the same as a squared, because technically anything in my absolute value will end up being positive, and any negative number squared will also be positive. So that's why it works. Here, if I think of, there is meant to be, I'll just fix this up, there is meant to be a little square sign there. So here, for the absolute value of a, the number will always be positive. Now here, if I square that number and then square root it, then I will also end up with a positive 5. If I have negative a and the absolute value of that, it's the exact same as the absolute value of a, which we can see here to our right side. If I have the absolute value of a minus b, I can change the signs and still have the absolute value sign, and they will be equal to each other. So like this over here. And lastly, now we proved before that these two are not equal to each other, but what does happen is that this left-hand side here of the absolute value of a plus b will always be equal to or less than if I were to separate them. So that's why we use the inequality instead of the equal sign there. Now here we're going to look at, well, how do we solve an equation with an absolute value? Because notice I can get two possible answers. So here, if I look at my first example here, so I have solved the absolute value of x is equal to 2. So that means that there is a distance of x of 2, and it means in both directions. So you can see here on our number line, I've moved 2 places to the left and another 2 places to the right. So can you see that I have 2 solutions, one which is positive and one which is negative? So I have one which is in the positive solution and one where it is a negative solution. So here we're going to put this into practice. So here with question 3, I want to solve the absolute value of x is equal to 8. So I have 2 possible solutions. I have a positive, so where x is equal to 8. And then I also have a negative, which is where x is equal to negative 8. So there are 2 possible solutions, one that's heading in the positive direction and one that's heading in the opposite, so the negative direction. We're going to apply this same concept for b. So here the absolute value of x plus 4 is equal to 7. So I'm going to look at having a positive and a negative solution. My positive solution is where x plus 4 is equal to 7. And then I solve this like a regular equation to get my answer of x equals 3. My negative solution is x plus 4, and instead of 7, it will be equal to minus 7. So thinking back to what we did up here, this is what we're doing to the same thing on the right-hand side here. And then I can solve like a regular equation to get x is equal to negative 11. If we look here at C, we're going to have, again, a positive and a negative solution. So my positive will be 2x minus 3 is equal to 9. And then I solve like a regular equation. And same with my negative, so 2x minus 3 can equal minus 9. And then solve like a regular equation. For D, it's going to be a positive solution. So I'm going as well as a negative. So my positive Again, like we did in C, we solve like we do normally. So here I can also get fractions. So here I've got 5 over 3. And here for my negative, remember it will be equal to minus 7. So here I'll get x equals 5 over 3 and x equals minus 3. Now with something like E, now here I have a fraction, however the process is still the same. So here notice that my absolute value is on the left and everything else is on the right. So here when I have a positive solution, it'll just be 2x minus 5 over 3 will be equal to positive 3 over 4. And here I solve like a regular linear equation. I multiply the 3 to the other side. Then I add 5. And then I divide by 2. I might just move my answer up here. So that's my positive solution. My negative, so I start with 2x minus 5. But here it is negative 3 over 4 because you need the negative solution. Then I solve like I do my regular equation by multiplying the 3 to the other side. I then add 5 to the other side. So x is also equal to 11 over 8. Now when I get to something like f, notice here that this numerator is the only part that has an absolute value. So here I want us to move everything else to the right-hand side. So we'll start by moving the half across. Sorry, that's over 4. And then we're going to multiply the 4 across. And notice now we have a much easier equation to work with. So here, my positive solution will be 0. And my negative solution will be negative 4.